Alright, Brandon, we're now working on the word problem.
And Victoria.
No,
Oh wait, no, Victoria's not in his class. I know, I always forget.
We should all get code names, guys.
Victoria's not here, she wasn't up front. Right. Okay. Lots of absentees today. The plane has a velocity of 125 miles per hour at a direction of 30 degrees. Can you see that's a 30.0? I don't know if you can see that where you are. The wind blows southwest at 20.0. Find the plane's velocity in the wind. So this when I say the plane has this velocity, that means without any wind or disturbance. But it's going to change when the wind starts blowing. Ask any pilot you know.
I know a pilot. That's be Paul Chan.
Papa Chan.
Alright, our first step in all of these vector problems, I'm going to give you a couple to do in a minute, is to draw a sketch of the vector problem. So we're going to start, I'll use the golden vector of course. So let's say the golden vector is 125 long and it's at 30 degrees. So you have drawn a vector. 30 is about a third of the way up quadrant 1 as we go toward 90 degrees. Remember this is 0, 90, 180, 270 in degrees. So say that's 30. And I'm saying that that's 125 long, not degrees, 125. Alright, so now we have to also draw a vector that is southwest. So we got to come up with an angle to that. So what quadrant is southwest?
Bermuda.
This is
Are we adding or
north,
subtracting?
east, south, and west. So north, south, west. Southwest is right here. This is southwest, this is northwest, this is northeast, and this is southeast. So that should make sense just from everyday knowledge of northeast, south, and west. So where, if it's going directly southwest, it's going to go right in the middle of that quadrant. What is that angle? We have to have it. And the problem is stubborn, it's not telling us. So we need to know what the angle is when we go from here all the way around to southwest. How can we get that value? It's a little bit of geometric thinking involved. Can you walk me through that?
Is it directly across?
It is, it's not directly across from that, but it's directly in the middle of this. So being in the middle should help. So how can I get that? Ideas, Emily Martin?
Well, if it's in the middle, you know that it's 45.
Right, so if this is a 90-degree slice here, cutting it in half, this much is 45. So now Emily, I want the whole thing. All the way around. So how do I get that? What two numbers will I add?
150.
One what?
I mean,
Oh, no, I meant we're adding.
well, I just did
vectors.
180 minus 30 plus
Oh.
45. I did 180 plus
Yep.
That's also your favorite too.
What is all this calculation? Say it again.
I did 180 plus 270 divided by 2
Is that what you're
minus 30.
taking my attention?
270 divided by 2 minus 30. So what you get?
195.
That's not it.
That's
not it.
You know it's 180 and then you can add 45.
That's not
Right.
exactly
See, from here to here is 180
Yeah.
because it's a straight line. And then we went another 45
Mhm.
long.
Did it
Oh, I
wrong.
was thinking about it.
You did it wrong, McKinney.
Like it goes right
It goes right in the middle.
in the middle.
Yeah, so if this is 90, this little bit is 45. So 180 plus 45 is all we do.
Whoa.
Alright, so I'm going to put the baby bear up. Does that baby bear look about the right length?
Yeah.
Well, if this is 125 and we want a 20 length, does this look about the right
It
length?
needs to be even smaller.
No, if this is 125, half of it would be about 60 something, half of that 30 something, And a third of that would, well, 2/3 of that would be 20. So I've got to cut this baby bear down to teeny baby bear.
We know that that's
Don't
180
cut
goes
baby
over
bear.
across like that.
Right.
But what about the 30? Wouldn't that make it less because you're going from where the vector is?
The 30 doesn't involve this angle. So this can go away. We don't need
So
that.
you're just doing it
You gotta
from
work
where?
with Brandon gets
Yeah,
all
just
of our
this is all by
commentary.
itself.
Okay.
All we know is this is
That'd
going
be great.
20 at southwest. So I
He's
cut
gonna
this
look and
way
then talk about the
down,
commentary. Yeah.
and I need a piece of tape
Oh my
or something.
goodness. Tornado.
If I put a magnet on it, we couldn't even see it. Does tape work on the boards with
Yeah.
chalk? We'll
It
find
does.
out. All right. So this is cutting. This vector is cutting this
Can you draw it?
quadrant in half. So it's a 45 from this angle, from this line. So I'll add 180 to get its final degree. It has nothing to do with this angle, 30. Man, that's a tough magnet. All right. Now, on your paper, do you have something drawn like this? A
Yes.
tiny, whiny, little
You
baby,
have a
teeny tiny vector pointing in the middle of this quadrant, and that is representing 20 in length. And this is 125. So look, if it's relatively the right size, this should be little compared to this. 20, 125. Even mine might be still too long, I'm not sure. Now we get to add those visually. So I'm going to pick up this vector and move it so the tail of the pink is at the head of the golden. So you can do that on your paper. So it's not
Move
much
that
of an
tiny
angle
white
difference,
angle.
but a little bit of an angle difference. And the resultant, draw in. When one vector is so much smaller than the other, it's
Like a
going to be
line.
very close, isn't it?
Probably.
All right,
I don't
we
know,
need a
but-
guess. So Zach, give us your best guess on this pink resultant vector. Right here.
105. I'll give it a 108 actually.
108 in length,
Yeah.
okay, and what angle?
Um,
The golden vector is 30.
27.
27? Alright. I think that's a pretty reasonable guess for the length of this dotted vector. So I took this, I added it graphically, visually to this, and put in the resultant, always from the origin to the head of the last vector, and guessed at its angle. Alright, let's do the math. Here we are adding these two vectors. Vector A is 125 at 30 degrees, and vector B, we had to calculate it, but it was 20 at 225. That's what southwest will always be, 225. Alright, so let's set it up the same way. Vector A is going to have 125 at 30, again, I'm writing it again. And vector B is 20 at 225. I need your calculators out to help me. We're going to do the x component first. So, I forget where we were, so starting, well, with Emily 1. Emily number 1, how do we find the x component of the golden vector?
You do 125 cosine 30.
Right, 125 cosine 30. Get me that number.
108.
Alright, and we'll just keep it at 108, and I put a little x there for clarification. Alright, now we're going to jump across the fence here and do y. Emily number 2, what expression?
125 cosine 30.
Alright, and what is that?
63.
Alright, 63. Alright, Zach, we're jumping down to B, and I want the x component of it. What expression?
It would be 20 cosine 225.
And calculate that, please.
Negative 14.
Alright. Y, Emily number 3,
20 sine 225.
and what is it?
14.
Alright. So I'm marking that with a Y. Alright. Brian, add X to X. So we have 108 and a minus 14.
Trying to write all this down.
Okay, go ahead. Let's pause and catch up. Are we taping this?
Mm-hmm.
This is part 2.
Mm-hmm.
Hey Brandon, we're in part 2.
Got our eyes.
They're both negative 14
Because this vector before it started was down here, remember?
yeah.
So it went back X and down Y, so we're expecting both to be negative. So it's X and
Yeah,
Really?
I know they're both negative, but like, is there any way to
for the length.
I was 2 off last time. Wait, is it 110?
That's right, we're at 45 again.
Actually,
You're
it's
right.
110.
You're
I should
right.
have made it 110. I'm
So it
gonna be really
happens
mad.
again. So even though it's not exactly 45,
How?
it's
You're right,
225, it still cuts that at 45. All right, Brian, are you with us
Oh,
yet?
what is it, 110?
Almost.
No, you can keep going.
I just
What
want
is
you
it?
to add 108 and negative
But
14.
is it- Is it
Alright. I'm not anyway. And negative
Let's
14.
go off the other way.
Uh-huh.
94.
So close.
All right. So that's my final, that's the resultant X component. And I'll put an R there just so you remember that it is. And Alex, I need 63 minus 14.
63 minus 14 is 49.
All right. Are we done?
Nope.
All right. So,
We're never done.
Pythag, inverse tan, and adjust. So, let's see. When we Pythag it, that's your turn, Hunter. We're gonna, once you catch up, 94 squared and 49 squared, square rooted.
I'm keen. I'm so close. That makes me mad. I know.
You're like 0.5.
I know.
All right, 106.
That makes me
No
mad.
way. Zach, you must have done the math before you guessed. All right,
Just
Emily
wait.
Martin, back to you.
Just wait.
We need the angle
Oh
of the
wait,
resultant.
there's more.
So it's an inverse tan of what
What is
number over what number?
Mouse rock.
49 over 94.
Right, it's the y over the x. And what do we get when we do that?
I got 27.5, so should that be 28?
28. Zach!
Close.
It was like 25.
I know, it's
I was like,
0.5
Zach,
off.
if you wanted like point.
What's wrong with you? You should be better than
So
that.
close.
Alright, that's an amazing guess, because we got 106 and 27. And that's from looking at the board at a pretty rough sketch, where we didn't know how big to make tiny whiny. So we did really good.
I mean,
All right,
tiny
so
one is 20.
106,
Take 20 off of
27
1,
degrees.
25, you get 105.
Alright.
And then I added
How
30.
many steps is that? How many step process is
Oh, I
that?
don't even know.
Ready?
Like
I mean, first you have to draw it, 1. Then you have to put on the vectors, 2. Then you have to add them visually, 3. Then you have to guess, 4. Then you put it into X,
You also have to
5,
have the angle.
Do that.
Well,
on
'cause
the angle
think
of
about it
southwest.
logically.
7,
You have a 125
8,
length
9,
minus 20
10,
because
11,
the tiny whiny is 20.
11 step
That's 105.
process, so-
But then you have to
Yeah, I
consider
know.
that it's on an
Right.
angle. So you add, give it 3, which is what I did. 108. I should have only given it 1. Then you look at the
Alright, we have
angle.
6 of these
It's
to
practically
do,
the
but we
same
are not
angle, but
doing them
because you
at
have
home,
tiny
we're
whiny
doing
coming out
them
of
in
20,
class.
you gotta
So
give
this is
subtract about 3.
classwork. We'll be
But I should've only
starting them
subtracted
today and finishing them tomorrow.
Logical.
We work together.
We can chat together, well, you have to do every step
Front and back.
yourself.
Brandon,
This is
you're
just
doing
classwork.
paper for
No, these are
classwork.
not due tomorrow, we're just gonna work
This
as
is what
far
it
as
looks
we can
like.
today and pick it up in class tomorrow.
A Boy Scout. Ooh.
So, first of all, read through the first one and draw it.
Send me too much credit today.
Alright, did you show him this?
Yeah, I showed
Okay.
him. He's already shown
Alright,
him.
Brendan, we'll be working on these. If we get any of them done, I'll show you the answers, but for now, I think that's gonna be it. So if you don't see a part 3, we're done. Bye-bye.